So section 1.2, linear equations and rational equations. All right, so a linear equation in one variable is just an equation that can be written in the form ax plus b equals 0, where a and b are going to be numbers and x would be your variable, so that would be the one variable. And a cannot be 0, because if a was 0, there wouldn't be an x, right? So you need to have a variable. And going through and solving, we'll do a couple of these right quick to determine if they, or I guess why they're an equation in one variable, or we'll talk about them. So we go through here. We see the x's. We only see x's. If we distribute, we still just end up with a number times x. So that basically we're only ending up with x's for all of these. But the last one I think is probably the trickiest looking. We could set these into the form ax plus b equals 0 by distributing, combining like terms, and moving everything over to the left-hand side, leaving you with a 0 on the right. All right, the ones that are not linear equations in one variable. So this x squared, we already know now that squared is a parabola, but squared's not linear, right? No? Okay. Okay, squared is not linear. There, we'll state it like it's new. Linear just means line. Okay, so the 3 plus 4x plus 7y is 12. Why is that not a linear equation in one variable? Yeah, there's two variables, right? You got that y. All right, what about here? The 8 minus 2xy equals 3x minus 4. Yeah, still two variables. Even though the x, y is together, it's still two variables. Okay. So we're going to solve these super fast. Ignore that 2. Pretend that's not there. So now we distribute. We're going to get 7x minus 28 equals x plus 2. We then, to solve, we're going to get our x's on one side and our numbers on the other. My suggestion is that we put the x's to where the x will still stay positive. So I'm going to go to the left with the x's. So minus x on both sides. So we're going to have 6x minus 28 equals 2. Then we're going to move the 28 over. And we get 6x is 30. One last step. Yeah. Divide by 6. So that we're going to get x is 5. It's a horrible 30. Let me fix it. There. If you want to double check your answer, you can take your 5 and plug it back in. Right? And if you get a true statement, meaning both sides are equal, then you did it right. For time's sake, we're going to not do that. I will give you all about 45 seconds to get a head start on this one. All right, for number 2, what's the first thing you did? No, it's the same thing. So distributing the negative 4 is the same as multiplying the negative 4 through the parentheses. So we're going to get the negative 20x minus 4. All right, and then combining the like terms. On the left side, negative 18x minus 4. So equals the 3x plus 17. And now we're kind of back to what we were already doing on the last one. We're going to move the x's one direction, the numbers the other. I'm going to choose to move the x's to the right to keep them positive. You don't have to always have them positive. I just find it helps alleviate some sign errors. And move the 17 over. And divide, and what do you guys get? All right, everybody get negative 1 for that one? Okay. So this is another example where if you wanted to plug it back in and check, you could, to make sure you got a true statement, meaning both sides were equal, because the negative could be tricky. Everybody good with all these? All right. Okay. So linear equations with fractions. Because there's an equal sign, as long as we do something to one side, we can do it to the other. So let's clear the fractions. To clear the fractions, you try to figure out what the least common denominator would be, and then you're going to multiply both sides, which is the same as multiplying all pieces, by that least common denominator. So for number 1, 10 will work, right? If you do 20, it's still going to work out the same. You're just going to be dividing by a different number, or you might have to reduce a little bit more. So multiplying both sides by 10 looks like this, but really I think about it like so. Yep, 10's the same as 10 over 1. All right, so with each of these, we would go through and reduce, because that is the same as 10 over 1. So 10 and 2 both reduce. 2 goes into 2 one time, so it's gone. And 2 goes into 10 5 times. So this first part here, I'm just left with 5x. For the second part, 10 goes into 10 once, 10 goes into 10 once. I'm just left with a 1, so minus 1, because again, whenever things go completely away through multiplication and division, you're left with a 1. All right, and then 10 times x over 5. 5 goes into 5 one time, 5 goes into 10 two times, so we've got 2x. And the 10 and the 2, 2 goes into 2 once, 2 goes into 10 5 times, so plus 5. And then we're right back to what we were doing before, right? Okay, so I'm going to move the 2x over. And then move the 1 over. And divide. So hopefully that's feeling super easy. And for number 2, what's the least common denominator for this one? 12. So your least common denominator for number 2 is going to be 12. And I'm going to give you all a second to go ahead and get started on it. And then we'll go through it. All right, hopefully everybody got to at least this part where you need to multiply 12 times all the pieces. Then we need to reduce. So again, the same as 12 over 1. So we're reducing the denominator of our rational expression with the numerator of our 12. So they're 12 over 1. So 3 goes into 3 once. 3 goes into 12 4 times. 2 goes into 2 once. 2 goes into 12 6 times. And the 4 is going to be gone also, right? So 4 is gone, 12 becomes right. So now I'm going to rewrite this. I'm going to take one extra step because this is 4 times 3x plus 1 minus 6 times 13 equals 3 onto 1 minus x. Is that okay? Okay. All right, so now we're back to kind of what we're used to. So now we're going to go ahead and distribute across the parentheses. So 12x plus 4 minus 78, is that right? Equals 3 minus 3x. I'm going to choose to take my x's to the left because, again, I like positive x's. You don't have to. It doesn't matter which direction you go. So 15x, I'm going to go ahead and put these two together. So positive 4 and negative 78 is going to leave us with a negative 74. equals 3. Then we need to move the 74 over. And we get 15x equals 77. And then divide both sides. Did it reduce? No, right? Is that okay? Again, you could plug that back in and double check. That's a little bit more taunting than like x equals 2, but your calculator's great with fractions, right? So you can just plug it in that way if you need to. This page okay? All right. Okay, let's do it some more, only this time we've got variables in the bottom. So going through, first off, for our LCD for this one, look at just the numbers. So we've got a 3, a 4, a 6, and a 3. What's our LCD, the number part? Yeah. All right, and then we need the variable part. What's the variable part going to be? Just x, exactly. Because the highest, we have x in 2 of these, and the highest exponent's just a 1, right? So it's just the x. So we're going to go through and multiply all pieces by 12x. I'm going to give you guys a second to work on it. All right, so the whole point of multiplying everything by the least common denominator, so we can cancel out all of our denominators. So I know that 3x goes away. It's going to reduce with that 12x. So the 3x reduces to a 1. 12x reduces to what? Yes. All right, so we got the 4 times 2, or just an 8 right here. And then this 4 goes away. 4 goes into 4 once, and then 12x reduces to 3x. So the 3x times 1 is going to give us plus 3x. And then 6x is going to reduce to 1. 12x becomes 2. Right, the x cancels also. So we have 2 times 11, so 22. And then the 3 goes away. 12x becomes 4x. So minus 4x times 1, so just minus 4x. And again, this is right back to what we've been doing. We're going to move the x's to one side, numbers to the other, and divide. You can move your x's whichever way you like. Again, I like mine to be positive. What do you mean? When do we keep them? Yeah. Right. So here we'll have a little quick side note. So if we have 12x over, oh, I didn't write the x. 12x over 3x, then the 3 goes into 12 4 times, and the x's cancel. So you're just left with a 4. But if you have 12x over 4, then the 4 goes into 12 3 times, but this x doesn't have anything to cancel it. And that's essentially what we're doing for these first two here. So we're looking at the 12x on top and the 3x on bottom. So we reduce that down to the 4. And then the 12x on top and just the 4 on bottom, we're only going to be able to reduce that 12, but that x is going to stay. So we still have the 3x left. You're very welcome. All right, let's finish chugging through this real quick. So we've got 8 plus 7x equals 22. You can subtract 8 on both sides. 7x equals, divide really quickly and run out of space. Okay, there we go. X is 2. And again, you can plug that back in and double check. All right, we're going to talk about 2 for a second, and then I am going to give you a minute to try it. The first thing I want us to talk about is finding the least common denominator. But before we get there, I want us to rewrite it. So we got 1 over x minus 4. And the only part we're changing is the denominator on the right-hand side. How does this factor? So minus 4 and plus 2, because those are going to multiply to a negative 8 and add to a negative 2. And if you're not sure, you can always FOIL to double check yourself. So now let's talk about the LCD. So least common denominator for this is going to be what? Yeah. All right, so there's your LCD, the x minus 4x plus 2. And again, I'll give you guys a good 45-second head start. All right, let's go ahead and cancel stuff. So what cancels with this first one? The x minus 4s. Right. Do you guys remember these are like having invisible parentheses around them because they're in the denominator? So any 1/2 of a fraction, meaning the numerator or the denominator, is like having invisible parentheses. All right, what about over here? And on the right side? Yeah, all that goes away. Okay. So we're going to end up with, I'm going to take an extra step and leave it in parentheses because I think this sign might be a little confusing. Because we have a negative, we have x minus 4, and we have a 5. So we'll come back to that right quick. We can. So if we do, what I'm going to choose to do is distribute this 5 first and then distribute the negative. You can do it either way, but I think it gets a little bit trickier whenever you distribute the negative first. I could have also rewritten this like this. And that's the same thing. Yeah, so this is the exact same thing, and this is probably my preferred way. I was just trying not to change order from here. Because here you're just distributing the negative 5. We're really just rearranging it because this negative is really like a negative 1. Because this is the same as plus a negative 1 times all that stuff. So this is just kind of rearranging and combining that 5 and negative 1. So I'll actually go ahead from this side if that's okay, because I'm guessing that's everyone's preferred method. All right, and if it's not, you didn't speak up. So, all right, so we need to distribute. So we're going to have x plus 2, and I'm dropping the parentheses now. There's nothing in front of there, so it doesn't matter. And then minus 5x plus 20 is 6. All right, now let's combine our like terms. We have x and a minus 5x will be a minus 4x, 2 and a 20, so both positive, so plus 22 equals 6. We need to go and subtract the 22 from both sides. So we get negative 4x equals negative 16. Divide both sides by what? You told me the tricky part, the negative. So make sure you're dividing by that negative 4. So the two negatives go away, leaves us with an x. And on the right-hand side, this reduces to what? A positive 4, exactly. Now, here's the one thing that I did not mention in the beginning of this page that I should have. So looking at number 1, what do we know for sure the answer will not be? Right, we know for sure x will not be 0. Why do we know that? Yeah, because we have a 0 on the bottom, we end up with we have a 0 for x, we end up with a 0 on the bottom, and we can't divide by 0. On this one, what do I know x cannot be? Well, I know the denominator can't be 0. So x cannot be, or, okay, so 4, it cannot be 4 or negative 2. Well, we just went through all this and said that x is 4. So what's my answer? No solution. Okay, so the reason we know that it can't be 4 or negative 2 is we're just taking these denominators and setting those equal to 0. So we have x minus 4, and we know that that cannot be 0. So whenever we solve, We know that x cannot be 4. And we do the same thing here. X plus 2 cannot be 0. So that means that x cannot be -2. And really, we should have done that first. I'm trying to be in a hurry, and I didn't. So my apologies. However, if you didn't do that first and you got 4 for your answer, if you had double-checked it and to put it in your calculator, make sure both sides are equal, your calculator is going to give you an error because you're trying to divide by 0. So your calculator will call you out on it that it's not the appropriate answer. So anyway, so no solution. Oh, these are kind of smushed together. Here, let me draw lines. I want you guys to go through and solve these, and then we'll talk about them. So I'm going to give you just a minute to solve them. All right, hopefully you've had enough time to figure out they're weird. All right, for the first one, what'd you do first? Distribute. So you get 4x minus 28 equals 4x minus 28. Maybe something dinged right here that it was weird, or maybe you just kept crunching through. If you kept crunching through, you probably would have moved the 4x's, so minus 4x. So you're going to end up with -28 is -28. Again, it could have dinged here for you, but maybe it didn't, because a lot of times you guys still move stuff. So you add 28 to both sides. And then you end up with 0 is 0. This is usually whenever you guys figure out you can't do anything else. All right, but how often does 0 equal 0? All the time. Same was true for -28 equals -28. -28 always equals -28. And same was true for 4x minus 28. So 4x minus 28 is always 4x minus 28. So I'm just trying to point out that if you caught it at any of those steps, it's fine. If you recognize that it's the exact same on both sides, and that your variables canceled out is the big key. So if your variables cancel out and you get a true statement, what that means is that all real x's are going to work. So you can pick any x value, plug it in, and it will give you a true equation or true statement. So your options are, that's an identity, a conditional equation, or an inconsistent one. Which one do you think it is? It's an identity. Right. If you had recognized that the 4x's were going to cancel because it was identical on both sides, you could have said it was an identity at that point. All right, for number 2, I'm guessing you moved your 2x's over. So minus 2x minus 2x. And then you get 3 equals -3. And then maybe, because you guys still like to move stuff, you like a 0 somewhere. So we'll move the 3 over. And then we're going to get 6 equals 0. And then you usually figure out you're done. How often does 6 equal 0? Never. So of your options of identity, conditional equation, or inconsistent equation, this is probably inconsistent. So 6 equals 0 is a lie. If somebody is inconsistent, they're lying to you, right? All right, number 3. Number 3 is easy peasy. So we're going to move the x's. I'm going to choose to move them to the right to make it positive and shorter. So plus 5x on both sides. So we have 3 equals 12x. Divide both sides by 12. And we can reduce this 3 over 12. Always reduce, unless it gave you very specific instructions not to, which I don't think it's going to. Always reduce. So we're going to end up with 1/4 equals x. So your options, identity, conditional equation, inconsistent. What do you think it is? Conditional. This is true if x equals 1/4. So given the condition that x is 1/4, this will be a true statement. Those okay?